Okay, so we had this packet that we did from yesterday with all these formulas on it. Some of them were actual formulas, and some of them were just diagrams that you're supposed to pull variables and dimensions off of. Any specific questions you have on that? Let me go through some answers for you here quick. Like the first 7, those are just generic phrases trying to find the equation or expression to fit it. For example, the product of 6 and x increased by y, that's just going to be what? 6x plus y. Good. Number 2, the sum of a and 12. Anybody? A plus 12. Very good. Subtract b from 21. 21 minus b. Subtract 21 from b. B minus 21. Divide r by s. R divided by s, or r over s. Twice L minus 1/2 P. 2L minus 1/2 P, or 2L minus P over 2, or 2L minus 0.5 P. The product of x and y divided by the square of m. xy over m squared, or xy divided by m squared. Either one of those is fine. So any questions on those first 7? Okay. So then after that, we use the pictures to do them. We kind of did number 8 together, so I don't need to do that one again. Number 9, find the distance between the indicated points. From A to B, well, A to B is just going to be the radius of A plus the radius of B. What's the radius of A? R. What's the radius of B? 1.5 R. Now we can think of R as being a 1R. So when we go to add them, it's 1 plus 1.5. So that's going to be 2.5 R. From F to C. Well, F, yeah, it has 2 of the radius for A, so 2 times R plus the 3/4 R. Yeah, again, you think of this as being a 1R, so 2 times 1R is 2R, plus 3/4 R is 2 3/4 R. And C, point B to C. Yeah, 1/2 R plus 3/4 R is 2 1/4 R. Point D to point E. Yeah, you've got R and R, so it's 2R. 1.5 and 1.5 is 3R. Then you got 5/8 and 5/8 makes 10/8 or 1 1/4 R. So that does add up to 6 1/4 R. How many of you got that last piece? How many of you didn't do the last piece? Claim it, be proud. Huh? Is there anybody that has no idea where that answer came from for the last piece? Wants me to go over it more? Okay. So anyway, we'll just kind of go through these. For 10, part A is 12.5 mm minus h. B is L minus I. There's that L minus little l, I don't know. Little l, okay. And C, 12.5 mm minus capital H. 11 is N minus P minus T. 12A, little r equals 0.866 S. B, big R is 1.155 little r. And C, A is 2.598 times big R squared. 13. Here we're asked to evaluate. You put the numbers in. Where'd it go? A should come out to be 52. B, 20. C, 6. D, 4. And E, 1. Any questions on those? Check the temperature. Okay, you really gotta stop drinking your breakfast, man. Okay. So, number 14. A is 1, B is 352, C is 5, D is 20, E is 2. Any questions on those? $15. A is 151, B is 96, C is 14.5, D is 8, and E is 126. Any questions on those? 16. A is 58, B is 144, C is 185, D is 1 3/5, and E is 109. And 17. A is 112.5 square inches. B is 10.6 inches. 10.607 if you rounded differently. 18. A is 128.3. B is 3,856.0 millimeters. 0.0. 19. A is 14.7 inches. B is 35.8 square inches.
What was 19A?
19A was 14.7 inches. 20. A is 73.8 millimeters. B is 138.0 millimeters. 21. 32.4 square inches. 22, 61.1 inches. 23, 27.2 millimeters squared. 24, 22.0 square inches. 25, 62.7 square inches. 26, 42.8 centimeters squared. 27, 5.1 inches. That's for A. For B, it is 215.5 cubic inches. And 28, 308.9 cubic inches. Questions? Okay. So there's just some examples of formulas that are applied to metalworking and machining. Maybe make this algebra stuff feel a little bit more relevant to you for a while. How many of you have had a chance to look through the Machinist's Handbook at all? A little bit. Do you guys still have to buy it as you opened it up?
What, like that?
Do you guys still have to buy it as part of your standard package?
Okay. You put it on the list, but it was optional.
That's an optional? Okay. It's a great book, and there's like, I don't know, it's like in the 28th edition or something like that now. It's 29. So I think I still have like a 13th edition somewhere in my office upstairs.
Mine comes today.
Yeah. It's full of formulas like these, and it's great information to have.
Is the guide kind of like a little practice book? More than anything?
You know, I haven't seen the guide in like 7 or 8 years or more now. But it used to be, well, I guess the one I saw was actually a math guide, so I don't know if there are different guides out there. But the one I saw was just, you know, kind of some of the more difficult formulas and how to do the math on it. But I don't know if
I
the...
got one too.
Okay.
I have for about a week now.
Okay, yeah. It'd be nice to take a look at it because I don't know if there's different kinds or not. Oh, sure. And it might be.
And I couldn't reference anything in the book, so here.
Oh, yeah, that would make sense. Okay. We have seen things like this. How would we do that? So what is 9 to the 4th power? 6,561. Okay, then what do we do? X to the 20th, where did that come from? Yeah, x to the 5th to the 4th power, you multiply the powers. So 5 times 4 makes 20. And then y to the 4th. Good. This is thought of as y to the 1, and 1 times 4 makes 4. Y to the 4, yeah, y4, yeah. 9 to the power of 4. A lot of people make the mistake, well, 9 times 4 is 36. No, you're still going to the power of 4. 9 to the power of 4 is 6,561. X to the 5th to the power of 4 is x to the 20th. So it looks like you're multiplying because when you take it to the power, the appearance is that the powers get multiplied together. But it is still taking x to the 5th to the power of 4. Even though it looks like multiplication, it's still a power. So I'm going to scroll down here. Let's do -5 to the 5th power. First of all, -5 to the 5th power is -3,125. Where'd the negative come from? -5. So if I take a negative number to a power, is the result always negative? Okay, depends on whether it's an even or an odd power. Very good. So then y to the 40th, you got it. Y to the 8th to the power of 5, you're going to multiply the powers. A power of a power, you multiply them. 8 times 5 is 40. And z to the 15th. How about this one? And yes, that is to the power of -4. Well, what does it mean to have 2 to the power of -4? Well, do you remember what the negative power means? No? 2 to the power of -4 means the reciprocal of 2 to the 4th, or 1 over 2 to the power of 4. In other words, 1/16. So this is 1/16. X to the -3rd to the -4th is x to the... What's -3 times -4? Positive 12. Y, again, y to the 1 to the -4th is y to the -4. If I really wanted to, I could write this as x to the 12th over 16y to the 4th. Where I just use that negative power, just like I did here to make this the reciprocal, I can do the same with the y to the -4. Make it the reciprocal of y to the 4th. 1 over y to the 4th. Either one of those answers would be acceptable.
Will you always multiply the power?
If it's a power to another power, you multiply the powers.
Even if it's the same?
Yes. If you have something like this, however, where I'm multiplying numbers, 2 times 7, those numbers still get multiplied to make 14. X to the 3rd times x to the 5th is x to the 8th. We add the powers when we're multiplying. Okay. And then if we had 12x to the 9th over 3x to the 4th. When we're dividing, 12 divided by 3 is 4. X to the 9th divided by x to the 4th is x to the 5th. 9 minus 4 is 5. Okay, how about that? Well, remember square root. If I ask you what the square root of 16 is, what that is asking is what number squared equals 16? Right? So what this is asking me is what thing squared equals x to the 8th. Well, if I'm squaring something, what am I going to do to its power? Multiply by 2, right? What times 2 makes 8? 4. So is x to the 4th squared equal x to the 8th? Yeah. So the square root of x to the 8th is x to the 4th. So with that thought in the back of your mind, what would be the square root of y to the 24th? What number times 2 makes 24? 12. Y to the 12th, if I square it, will that give me y to the 24th? You bet that equals y to the 24th. So yes, y to the 12th is the square root of y to the 24th. Do you see a pattern developing at all yet? Like the square root of z to the 16th should be z to the 8th? Where'd 8 come from? Half of 16. Yeah. When I take the square root of y to the 24th, half of 24 is 12. It's y to the 12th.
How can you take 16 and divide by 2? I understand when you have z to the 8 and you put it to the second power equals z to the 16. But if you have the square root of 16, it's 4.
I'm not taking the square root of 16, I'm taking the square root of z to the 16th. See, you're confusing this. The square root of the number 16 is 4, right? The square root of z to the 16th is z to the 8th. Just like,
How do we calculate that?
I'm getting there, just give me a second. Just like when you do this, right? You don't do 4 times 2, you do 4 squared, right? Which is 16. But here you don't do 8 squared to get 64, you do 8 times 2. So the powers work differently than the numbers and the coefficients. Same here, the 16 here, since that is a number, you're taking its square root, get the 4. But this is a power.
Can you scroll back up a second? Okay.
Okay. So, let's say we have the square root of 81, x to the 12th, y to the 4th, z to the 20th. What do I do with the 81? 9. Square root of 81 is 9. Since that is a number, it's a coefficient, we actually do have to square root it. Now technically it could be positive or negative 9. We're just going to go positive 9. How about for the x? X to the 6th, y, 2, and z, 10. Not so bad. Better than sharp stick in the eye?
So is it always divide by 2 unless you have like the third square root?
Oh, if it's got a 3 there, it's not square root, it's third root.
Third root.
Yep. So now we would have to do the third root of 125, which is 5. And it is just 5 because it's an odd root. Remember, odd powers can give you negative numbers. Even powers are always positive. So even roots, like square root, fourth root, sixth root, you can only do of a positive number. Odd roots, you can do roots of negative numbers. So the third root of 125 is 5. How about x to the 18th? Divide by 3 now. X to the 6th. And y to the 4th. Divide by 3. It's okay. How about this one? What's the 6th root of 15,625? It would be 5 or negative 5. And x to the 2, x squared, yep. Y to the, yep, 30 divided by 6 is 5. And z, perfect. I'm going to show you this one, just because, well, I can. How about that one? You can do x to the 3.5 or 3.5. Commonly, it's done like this. We split that into square root of x to the 6th times x. Why would we do that? Because the square root of x to the 6th is x to the 3rd times the square root of x. We're not going to do that in here, but it can be done. But leads us to a question, however. What does that mean? X to the power of 1/2. If I had 9 to the power of 1, of course that's 9, right? If I have 9 to the power of 0, that's going to be 9 to the power of 0 is going to be 9 to the power of 0 is going to be
9 to the power of 0 is going to be 1.
anything to the power of 0 is 1. So 9 to the power of 1. You should never know that in your life, is what you're saying. No, I should not know that. I'm ashamed of myself for knowing that. 9 to the power of 1/2 has to be somewhere between 1 and 9, right? Where's it going to be? Well, let's look at this. When I do the square root of x to the 4th, what do? I divide the power of 4 by 2 to get x squared, right? So if I did the square root of x, that's the power of 1, right? So divide the power by 2, what's 1 divided by 2? 1/2. X to the 1/2. X to the 1/2 is the same as the square root of x. 9 to the 1/2 is the same as the square root of 9. I told you before when we did order of operations at the beginning of the year that powers and roots are all exponents. They all fall under that same heading. Powers and roots are the same thing. They are. How about 8 to the power of 1/3? What do you think that is? That's the third root of 8, or 2. If you want to punch into your calculator and verify, go for it. Get it to work? So, yeah, why not? How about something like that? Well, Yeah, 3/2 is 1.5. But it's easier to use that exponent as an improper fraction than it would be as a mixed number. And I'll show you why. Because in this form, I can do this to it. I know what 25 to the 1/2 is, right? It's the square root of 25, correct? Is what I just wrote here equivalent to this? Well, when I have a power of a power, what do I do with the powers? Multiply them. What's 1/2 times 3? 3/2. So I can split that power up like that. And so now what is 25 to the power of 1/2? What's the square root of 25? 5. Power of 3, which is going to make 125. You got it. So how about this one? I can split that up. 2,125. And I usually keep the denominator first to the 1/5 and then to the 3rd. So what is that? And again, 1/5 times 3 is going to give me 3/5. What is 3,125 to the power of 1/5? It's 5, right? So that's 5 to the 3rd power, or 125. How about this one? Your calculator will do it. Should give you 16. Question is, why does it give you 16? Did it give you 16? So why? .4 is written as a decimal, but it is, every decimal is really a fraction. It's 4/10, right? So now that can be split up into 1,024 to the 1/10, the power of 4. 1,024 to the 1/10 is 2. To the power of 4 is 16. You're looking confused, Richard.
He always looks that way. Richard says that too.
Yeah.
Young man.
You may know what you're talking about, you just don't.
Doesn't want me to know. He knows. If I know, if I think he knows what I'm talking about, if I think he understands, I'm going to hold him responsible for it. Is what you're saying?
Yep.
So without your calculators, tell me what that means. Well, 1.2 is 1 2/10, right? Or 1 1/5 if you reduce it. Or 6/5. Why did I do that? Because it's easier to work with powers, exponents, as improper fractions. So this is 243 to the power of 6/5. Can I do a 5th root of 243? 243 to the 1/5 is a 5th root. Fifth root of 243 is 3.
Is it always the end number?
No,
Okay. I know that.
those are just the easy ones. Yeah. So it's 3 to the power of 6, otherwise known as 729. Let me make sure I come up with one that isn't just the end number for you. How's that? Now I gotta think. How dare you? There, how about that one? It's not 3. 343 to the 1/3 and then squared, right? What's 343 to the 1/3? 7, and then squared to make 49. What do y'all think? Depends. Your calculators will do it, yeah. In the big book. You want to look at page, gotta make sure this is right, 345, I think? 345, yep. Exercise 13-6. I'm gonna double check this because I've got a new edition of the book and I want to make sure I've got all the pages updated correctly. Nope. But last year we used the old edition.
Oh.
Yes, that is correct. Page 345, exercise 13-6. Also on page 349, exercise 13-7. And then in your little books, you're looking at units 26 and 27. That should keep you occupied for a while. Yes.
You said 13, 6, 13, 7.
Yep. 13-6, 13-6.